So the plan for today is to have a look at a coordinate geometry cheat sheet. So cheat sheets are not for the traditional classical use of the word cheating. What we use them for is like a one-page summary. So everything you need to know about this topic, all in one place. And then as you're working through the more complex questions, you work to start with your cheat sheet beside you, and then you gradually move away from using it as it gets more and more stuck in your head. But what's nice is because you're doing sort of a chapter over several lessons, then sometimes things get a bit disjointed, and sometimes you remember one piece and not the other. So to have everything all in one place is actually really useful. So coordinate geometry. We're going to cover what should be in this cheat sheet, and then the idea is next week we will do past paper questions actually using the skills. So, first thing you come across will be the midpoint. Okay, so midpoint, middle point. Okay, we're halfway between 2 points. So if we have A and we have B, then we would say that our midpoint is here in the middle. Notation, it's important. How do we say midpoint? Midpoint gets a capital M and then a subscript AB. So there is no excuses. Here are lines as you will find on your paper. The M is a capital, he stands on the line. The AB is like the opposite of an exponent. So instead of being raised in the sky, he sinks down and he sits on the line. Okay, that's how we do a subscript. And how do we average things? Well, we add and divide by the count. So it's exactly the same thing here. Okay, we want coordinates for this midpoint. So we need to take our two x values and divide by 2, and our two y values and divide by 2. Because that's going to give us the average x and the average y, and that's going to land us right in the middle of where we want to be. So, midpoint. Things to remember. Brackets and the comma. Because you are not doing this as just random calculations. If you are calculating a full midpoint, you're calculating a coordinate. So we need to structure it like coordinates. So let's say we have A is 2, 3, and B is 6 minus 4. Then the midpoint of AB equals, open brackets, 2 plus 6 over 2. 3 plus minus 4, so minus 4 over 2. So midpoint here is 6, 7, 8 divided by 2 gives us 4. 3 minus 4 is minus 1, so minus a half. There's another note for you. See that fraction? We love fractions. If you have a bad relationship with fractions, you're going to get up every morning starting tomorrow. You're going to look in the mirror and you're going to say, fractions are my friend. Okay, you have to be able to work with fractions for AS Maths. Your life is just going to be so much more worthwhile and so much easier in certain topics, and it's required for certain topics because you'll get yourself in a twist. So we leave them as a fraction. When it comes to coordinate geometry, we actually even leave those fractions as top-heavy fractions. We don't want mixed numbers. Okay, so a few extra notes for this slide. I love fractions and no mixed numbers. Right, so there's our first thing for our cheat sheet, midpoint, and a formula. So next one will be distance. This is our length formula. So if you ever see two letters standing together, like A, B, C, D, E, F, A, E even. Okay, what they're asking you there is the distance. So, AB equals the square root of x squared, x2 minus x1 all squared plus y2 minus y1 all squared, no lazy square root signs, all the way to the very end. Okay, where did this come from? Think of Pythagoras. H squared equals a squared plus b squared. So h equals square root a plus b. This is a nice way to remember that it's the plus in the middle between them. And therefore, if the plus is in the middle, the minuses must be in the brackets. Okay, you do have to be very familiar with these. You have to learn these formulas. Where does it come from? Well, if we put our AB on a slant now, AB, this length here, if we draw ourselves a nice, beautiful right-angled triangle, well, is ripe and ready for Pythagoras. So, h squared equals a squared plus b squared. So, to get this side at the bottom, we'd need the difference between the x coordinates. To get this side on the top, on the side, really, we'd need the difference between the y coordinates. So, that's why we have x difference squared plus y difference squared, and then we square root the whole thing because we want length. Okay, so that's your distance. So for example, if we had A, which was 2 minus 5, and we had B, which is 1, 3, and I can see myself running into problems because I didn't bring my calculator to class. So let's see what we get. AB equals square root of 2 minus 1 all squared plus minus 5 minus 3 all squared. Right, so AB equals the square root of 2 minus 1 is 1 squared, which is 1. Minus 5 minus 3 is minus 8. 8 eighths are 64. So AB equals the square root of 65. Now, off the top of your head, factors of 65. 1 and 65, 2 no, 3 no, 4 no, 5 yes. We would have 5 times, that's 10, 13. Okay, so it doesn't look like we got any square numbers in these. I'm going to go out on a limb and say, I'm hoping, fingers crossed, this is simplified surd format. If it was a square root of, say, square root 8 that we'd ended up with, then we would simplify our surd to 2 root 2. But we're going to leave it in surd format, unless told otherwise. Okay, because you always want to remember pure maths is where we're being precise. It's where we're being exact. So we don't want to be sort of rounding our answers where we don't need to. So if we've got a surd, work with the surd. Okay, so that then gives us distance. So we've done midpoint, we've done distance, and your third of the 3 basics is gradient. So, gradient notation, lowercase m, AB on the line. So, for those who like to cheat, because I write on a whiteboard, there's your lines so that you know. MAB equals y2 minus y1 over x2 minus x1. And this one is really important. Okay, so you've got a few things. You must have y over x. Okay, how to remember it? Well, the y's got this great big loopy thing, so he's got to go on top to fit. Okay, so must be y over x, and you must line up. There's your 2's and there's your 1s. So your coordinate pairs must line up. So if you do it the other way around, y1 minus y2 over x1 minus x2, fine. I don't care which is your second coordinate and which is your first coordinate, but the thing is that your x's and your y's must line up in order to make this work. Otherwise, you're going to get all sorts of funky things going on. So if we had an example, let's say, we don't want examples in orange, we want examples in blue. A is now the point 1 and 3, and B is the point 2 and minus 5. So MAB equals 1 minus 2, okay, so we're going with the first one is A, and 3 minus 5. So I'm going to write it here as another reminder. Substitute using brackets. There is a whole lot of swear words associated with AS Maths. The S word, the B word, okay, S word is signs. Your B word is brackets. Because these are little things that you do in the sort of second step of your question, which then stuff you up for the next 6 marks, 0, even though you understood what was going on. So don't make silly mistakes like this. Be careful, be precise. Okay, so substitute using brackets and it will save you a lot of headache and heartache. Right. Be careful. I was testing you all. And we have the first mistake. See, teachers are also humans, and when they're doing too much, they don't think straight. Y change over X change. Thank you, Emma. So if we do this correct way round, we would have 3 minus 5 over 1 minus 2. So Emma gets the gold star. Everybody else, are you sleeping still? It's late already. Okay, so 3 minus 5 is 3 plus 5, which is 8. I hope. Double check me now. 1 minus 2 is minus 1, so our gradient is minus 8. So, note to self, check and be careful. Substitute using brackets whether you got it in the right position or not, but try and make sure it's in the right position. Okay, now I'm a bit thrown. Check the notes. Okay, so, sorry guys. Let's have a look at a few other things while we're on the subject of gradient. We want to be sure of what is a positive gradient, a negative gradient, a zero gradient, and an undefined gradient. So a positive gradient, we're always working from left to right. So positive goes up, negative goes down, zero is a flat line, and undefined goes straight up. Okay, so let's make sure we don't get these two back to front. The other really important thing is parallel and perpendicular. When you use these in a question, you're often going to find out that you're working with information about the gradient rather than the gradient itself. So the more you understand the gradient and how it relates to information that you're given, then it makes things a lot easier in life. So parallel gradients means parallel lines are going in the same direction. They're never going to meet. They're never going to cross. So M1 equals M2. So here we're using our little m for our gradient, and we're using just the numbers 1 and 2 because we don't have MAB and MCD. So we just use subscripts 1 and 2. Perpendicular, things get more funky. The really cool relationship that says the product of perpendicular gradients is minus 1. So we can say M1, M2 equals minus 1. So that then has implications of how we can get a gradient if we have the perpendicular line and all sorts of things like that. And we'll talk about that next week when we actually do some calculations with this. For now, here's your cheat sheet. Your formula for the gradient, formula for parallel, your relationship for parallel, and your relationship for perpendicular. And a very strong reminder that we have y change over x change. Right, everybody happy? Any more errors on this one, or can I carry on? If I see nothing, I will keep going. Right, it's saved. So hopefully it's correct. After gradient, we need some important friends. Our two important friends here, let's split so we can look at them both at once. We have y equals mx plus c, and we have y minus y1 equals mx minus x1. So what we're talking about here is straight lines. And maybe I should have said that at the beginning as well. When we're doing this coordinate geometry cheat sheet. Obviously, I talk too fast. I can't even keep up with my own words. Pause. What we're doing is we're working with our straight line relationships. There's some funky things at the end of this section where you get into curves. So we can talk about curves in another session, because that is another understanding that it's really important. We can tie it to quadratics that we were doing for the last 2 weeks. Okay, so y equals mx plus c, you've probably already come across. M is our magical gradient. C, why we had to use lowercase m when we were talking about gradient. Now we got consistency. MAB, gradient of AB. M1, M2 equals minus 1, perpendicular gradients. And now y equals mx plus c, there's our gradient. C, our magical C, is the intercept on the y-axis. So this helps us in a variety of different things. Again, we can pull information about our line out, okay? And we can also then take information and get it in. So for example, if we had, y equals 3x minus 2, then we can say from here, gradient equals 3, y-intercept equals, y-intercept x is always 0 and minus 2, because c is minus 2. So when you're aiming for an answer, you're aiming to put it into this, but just bear in mind also, if you had something like 2y equals 8 minus 5x, we don't have y equals mx plus c here. What we need to do is we need to have some fun and games a bit first. We would need to rearrange. So dividing through by the 2, we get y equals 4 minus 5 over 2x. And then if we want to be traditional, y equals minus 5 over 2x plus 4. So your gradient equals minus 5 over 2, and your y-intercept is 0, 4. So it's really important that you're in that format and you're pulling your information out of the correct format, so you're avoiding making mistakes. Okay, so y minus y1 equals m, x minus x1. Bright green. Green's a good color. This is one of the most important things we will talk about when we're working through this. Because if you're doing a straight line coordinate geometry question, there's a 99.9% chance that you're going to be using this formula. If you are building a line, you must use this formula. You've come across other ways to do it at IG, but they're not as efficient, they're not as straightforward. So at AS, your mark is actually for using this formula, not for your final answer, for using the formula. So, can't spell you now. If you want marks, use this formula. What do you need? Well, y and x, there are variables that are heading into our equation of the straight line. So we need this y1, x1, and we need this m. Well, we've come across all of this before. M is gradient. So you need two things. One is the gradient. And okay, obviously things are just not happening at the moment. When you start a list, you normally start with a number 1. Okay, the first thing you need is a gradient. The second thing you need is a point on the line. Okay, so gradient is our m. Point on our line is x1, y1. Actually, I don't want to put it there. I want to put it underneath. Okay, so I could tell you the gradient is 3, the point is 1, 2, and you can plug it in and you can use it. Thing is, life is a lot more fun than that at AS. So what you want to do is you need to keep your eyes open. You need to read your questions very carefully because you might not get told these. You might get told information about them from which you can then calculate. If I tell you that my line I want to calculate is parallel to another line, woohoo, now I can get the gradient from there, gradient's the same. I could tell you that it passes through the origin. Well, now my point is 0, 0. So there's all sorts of different ways in which they can give you information about the gradient and or the point without giving you them exactly. And then you've got to think through so that you can plug the right things into this formula. Okay, so there is your two equations for lines. You've got y equals mx plus c, such a wonderfully handy format. And then you've got your formula, y minus y1 equals mx minus x1, to help you actually get the equation of the line. Are there any times when we should use y equals mx plus c in preference? Not for calculations, only for final answers. Okay, but then sometimes y equals mx plus c is full of fractions, so you don't want to use it then. So when you go through the lesson about y equals mx plus c and formats of lines, then you'll see different formats and slight changes and subtleties. The thing is that you follow the general guidelines unless told otherwise, but whenever you are calculating the equation of a straight line, you must use y minus y1 equals mx minus x1, which is why that formula is your new best friend. Right. So there is one other piece for your toolbox. And that last piece is intersections. So we've got two stories here. We've got the story where we have lines like this, and we're looking for that intersection. We also have the story where we have a shape. So let's just give ourselves some numbers. Let's call this one 1, 2, which would make this one 4, 5, this one 4, 2, and this one can be 3, 3 for fun and games. Okay, so then we call them A, B, and C, and D. Here we're going to go A, B, C, D. And let's say that we've got A would be 1, 3. D is going to be, whoops, not 1, 2, 1. And C is going to be 5, 3. Okay, so two different situations and two different methods to keep in mind. The method that is always going to work, okay, is simultaneous equations. If we solve for the point that occurs on both lines, then we get the intersection. But sometimes life can get a little bit more fun. And this one is this sort of thing where we now talk about the vector step. So what we would say here is that to get from D, which is known, to A, which is known, is exactly the same as to get from C, which is known, to B, which is unknown. So some of you might not be so friendly with vectors, so this is not anything fancy, okay? We don't have to use vector notation until after you've finished your vector lesson. Okay, so let's do it. For this one, to go from D to A, for X, we're going -1. So X movement equals -1. Y movement, we're going up from 1 to 3, so it's +2. So if we then starting at C, which is 5, 3, B would be 5 minus 1, 3 plus 2, which gives us, B is 4, 5. Done. So we could have built line equations. We could have looked at at DC, got the parallel gradient, got AB, then we could have looked at BC parallel to AD and perpendicular to DC. We've got so many options of building lines. But the thing is that we'll be sitting there for 2 pages of calculations when all we needed to do was think a little bit. So always bear in mind that yes, your simultaneous equations is always going to work, but think if you can see a vector step when you're looking for an intersection or a point in the middle of nowhere. Okay, these will be very, very helpful. So what you're going to do and what we're going to look at next time is looking at past paper questions to see what have I got, where do I need to end up, and then how do I do the calculations to get from what I've got to where I need to be. So we're going to use these cheat sheets. So I've done them in a series of things, but what you're going to need to do now is you're going to get yourself one piece of paper and get everything onto it. And it's more than possible to do so because my notes for this entire lesson fitted in half a page. So you're aiming for what are my main points, what are my formulas, remember them and learn them. And that's 11 o'clock, which means it's time for the stats Q&A. So if you have any questions, put them on the chat or bring them to the Q&A tomorrow. Otherwise, I shall see you tomorrow or chat to you online. Shout if you have questions. Have a wonderful rest of your Wednesday. Tuesday even. Goodness gracious. We'll get there in the end. See you guys.